this video, I'm going to talk about an improved design mechanical tool length setter for CNC milling tool length setting work. So if you looked at my channel about a year ago, I produced this video, Toolsetters for Tormach and other CNC mills, and I go into which tool setter for you, an LED version, a mechanical version, a digital automatic version, an off-machine system. And so have a look at that video if you haven't seen it, because it's a good introduction to this improved design product I'm looking at here, or just a design of a tool setter that you might want to make yourself. So this came out really as a winner of the comparison, I think, for most people, for reasons that are explained in that video. I won't go into them here because it'll just be too long-winded, so have a look at that video for a background. For many people that will be a good option, but there are problems with that type of tool setter. That little blue Chinese tool setter, I pulled it apart here and uncovered some fundamental design issues with that little Chinese mechanical tool setter, dial indicator based tool setter. And so I've redesigned it with those problems removed, and if you're interested, this video will be explaining about that. You might want to make one of these little tool setters. To find that video, if you go to my YouTube channel Thread Express, that's the home page that you will see there. Some of you might not be aware, I've updated my playlists. Click on playlist and you can see all the content of my channel there split into different categories. Tormach specific, mill work holding, mill tool setters is the one you would want, showing part 1 and part 2 there. Well, let's have a look at the accuracy of the little blue Chinese tool length setter. It's really important that that flat datum plane across the two buttons and the plunger is consistently staying on 0 with the needle. So let's have a look at that. So now we are probably about 1/100th clockwise past 0. Let's just move it a few more times up and down. So you can see there I'm about 1/100th before 0. Try it a few more times. There, we're pretty much on 0. I've got the camera in front of me really, but I'm just trying to sort of show you the problems with the variability of this cheap one. See, it's sort of shifting 1 or 2/100ths either way. In practice, I find there's 2 or 3/100ths variation in its 0 repeatability when you're manually checking it, when you're manually setting this part of it between one use and another. And that's largely because it's made to very loose tolerances. The plunger is a loose fit in its bore, and the little slot that the pin from the dial indicator links into is on an angle, and all those little errors are pretty difficult to fix, and they're made because the unit is built down to a price, mass produced out of loose fitting components. You know, I thought I could make a new plunger, harden and grind it, and cylindrically grind it to a very close fit. See there, we're about 2/100ths out. And then it would be a lot more accurate. But the trouble is the hole it's set in, the bore, is probably tapered. So then you say, all right, well then you lap out the bore, but then you have to make a lap. Then you carefully measure it and you make a close fitting plunger. Well, by the time you've done that, you're halfway towards making a completely new setter, which can be designed so that those problems are not present in the design. I I've recently been putting together some of the Hallmark impact tolerant touch probes, the 12mm shank and the TTS shank versions. If you've been watching my video series, you probably notice I put together, assemble a batch of maybe around about 20 or so. But when I make the actual components, I make those in much bigger volumes. I tend to do a production run of each component, maybe as many as 150, something like that. Deciding on production run size is always problematic, isn't it? If you choose for a large volume, then it's much more efficient and gets the price down per component. But there's problems with that. It's much more tedious, difficult to keep concentrating and keeping the quality at 100%, and also you don't have the ability to tweak the design. If you're doing very large runs, you're stuck with those components that you made when you did the last big run. But if you do small runs, you can tweak the design. It keeps the interest up and the quality up. But then you are making them less efficiently. I like to try and not have the run sizes too big because I really enjoy making small subtle improvements, and you can't do that if you're just using parts from a static design. The design of this blue Chinese tool setter is very compact, but the problem is that you've got the dial indicator and the plunger as two separate mechanisms. If you like, it's like that. You've got a dial indicator in front of the plunger and you've got a pin connecting the two, and that requires high precision, which is just not easy to obtain at a low price. Whereas this simple design is just using the mechanism of the dial indicator with just one simple movement of the dial indicator. There's inherently a lot less things to go wrong. So here I'm going to test it for repeatability. If you're wondering why I've chosen this design, have you had a look at the introduction video, Which Tool Setter? I'll link it in the description below. Assuming you've seen that video, you can see why I like this design. I'm going to test it for repeatability here. I'm considering it as a product for Hallmark Design and their website. Please let me know if you'd be interested. I need to do quite a bit more testing and use it over a period of time to be sure that it would be suitable as it is, or whether I need to make some further refinements. Let's just run a bit of a test on it for repeatability. Well, thanks for watching that summary so far. That's the condensed version video of this new improved design tool length setter. And if you're interested in it still, then please stay on and I'll put some more information in this tail end of the video. So I'm not sure if it's a product that would suit Hallmark Design's product range or not. I'd like to hear your feedback. If you would be interested in buying one of these, please send me a message through the Hallmark Design website. Go to contact and send me a message if you'd be interested. Now, this wouldn't be a low-cost tool setter like the little blue Chinese one, because it's hardened and ground, and and it's made in a Western country, so it would be a lot more expensive. You might prefer to make one, in which case stay on and I'll put some clips starting in a few minutes on how you could make your own, and some fuller video clips of how I made this prototype. But if you'd be interested in one to be included in the Hallmark product range, please send me a message and let me know. Alright guys, I'll put some more information in there for you now. Cheers. So this might be a really good project for you to make your own tool length setter. It's quite straightforward, a lot more straightforward than making a probe. There's just a top and bottom plate, and a central spacer plate. You probably want to buy a little dial indicator first. This is a fairly compact mini dial indicator so that it's not too bulky. And if you buy that size dial indicator, you probably want to get Imperial or Thou if you're in the USA. Then it would be this sort of size. But you can proportion it according to this. This is my rough sketch of this prototype. You could pause your screen and print that off. So basically it's about 70 millimeters, the central spacer block here, and the little top and bottom plates are 50 millimeters by 30 millimeters. I've got a plunger face there of about 22 millimeters diameter. That dial indicator is about 40 millimeters face diameter. The overall height is about 88 millimeters high, so it's quite compact. I've got some slotted screws in the back there with spring washers between the dial indicator and the back plate, and that allows you to adjust that contact face, that anvil face, level in both this direction and this direction, and also to slide the whole dial indicator up and down if you want to adjust the needle resting position. It's not the most elegant of ways of adjusting it, but you really only have to make that adjustment once. But there's probably better adjustment methods. That's just my first idea for this prototype. So these plates are just held on with two little 4mm cap screws, I think. So it's pretty straightforward, a nice little project for you. Ideally this should be made out of hardened steel. Well, at least this little anvil surface should be hardened steel, and this top surface ideally should be hardened steel, and the base really, and the spacer even as well, because if you start making things out of aluminium, you get thermal expansion at different temperatures. It changes and you won't have the same accuracy, and also you're going to get wear and scuffing on these surfaces. So you could make them out of tool steel like O1 steel and harden them up. If you don't have your own little heat treatment oven and surface grinder, you can harden them up with an oxyacetylene torch and quench them into old engine oil and lap them on a plate with a piece of wet and dry paper, and that would be fine as well if you really wanted the ultimate construction.